The power rule for negative powers or negative exponents of x is the same as the regular power rule for derivatives. I multiply the coefficient of the term by the exponent and I subtract 1 from the exponent. Just remembering that when I subtract 1 from something like -1, it's going to become -2. So this is where I told you last year that knowing how to convert between radical and rational exponents, between like the square root of x equals x to the 1/2, and knowing how to convert positive exponents to negative exponents and back becomes very helpful in simplifying some of our work when we're finding derivatives. Let's take a look at an example in the next slide. So if I were to take a look at this particular example, y equals x squared plus 3 over 2x, it wants me to find the line tangent to the curve at that point 1, 2 of that thing. So what are the two things that we always have to have when we want to come up with an equation of a line? Do not ever forget this. The equation of a line always requires a point and a slope. As long as I can always find a point and a slope, I can find the equation of the line. So up to this point, if you have not learned that finding the derivative gives us the equation or the value of the slope of a curve at a point, you need to learn that now. You need to learn that last week, last month. The derivative is the slope. So in order to find the equation of the tangent line, we're going to have to take the derivative of y and find the equation for the slope. So let's do that first. Now, you look at this and you see, oh, you can use the quotient rule. And that's true, we could use the quotient rule, or we can also use negative powers. So let's look at how we can manipulate y equals x squared plus 3 over 2x to turn it into negative powers, which might be a little bit easier to differentiate and solve. So let's go ahead and separate this into two terms, or two polynomials. I can say that x squared over 2x plus 3 over 2x is the same thing as x squared plus 3 over 2x, because when I add fractions, I keep the denominator. Now I can take this x and I can take it to the top by making the exponent negative. So I can say that this is equal to x squared times x to the -1 over 2. And I can say that this one is 3 over 2 times x to the -1. Oops, that should be a plus there, sorry. So if you followed along there, all I have done is I split it out. I now am taking the x up top and calling it a -1 by my rules of exponents. So now that I can go ahead and simplify this, it becomes x squared times x to the -1 just becomes x on top. And you can kind of see that right here. If I factor out an x here, I am just left with one x on top. And dividing by 2, the 2 on the bottom, is the same thing as saying 1/2. So y equals 1/2 x plus this 3/2 here times x to the -1. So since I've done that, I can now go ahead and differentiate using my negative powers. So y prime, we'll put the derivative in pink here, y prime becomes 1/2 x. So if this is to the first power, 1 times 1/2 is 1/2, and the x drops because it becomes x to the 0. Now over here, when I multiply my 3/2 by -1, it becomes -3/2, And then when I subtract 1 from my exponent, it becomes negative 2. So it's minus 3/2 x to the negative 2. Now the slope at 1 is going to be, the point that I'm looking for is 1, 2. So to find the slope at x equals 1, I'm going to have to plug into my derivative formula. So y prime equals 1/2 minus 3/2 times 1 to the negative 2, and 1 to any power is just 1. So this becomes 1/2 minus 3/2, which becomes negative 1. 1 minus 3 is negative 2. Negative 2 over 2 is negative 1. So my slope is negative 1. And my point is given to me up here is 1, 2. Now remember, I get a lot of students that work these problems out, and this is all I get. I have to have the equation for the line. So we can use the point-slope form of that, y minus y1 equals m times x minus x1, or whatever version you want to use, as long as I have this a linear equation in y equals mx plus b form. So if this point right here is x1 and this point here is y1, I'm just going to substitute into my equation y minus 2 equals, my slope is negative 1, and x minus 1 if negative 1 is, or positive 1 is my, x point. So now I'm going to just solve this for y. Y minus 2 equals negative x plus 1. I'm just distributing. I'm going to add 2 to both sides. So I get y equals negative x. Let me fix that up a little bit. Maybe. So y equals negative x plus 3. That, my friends, is the answer to the question I'm being asked. That is, find the equation for the line tangent to the curve. Knowing that I always need a point and a slope, and knowing that derivative is slope. All right, we will work more on these, I promise.